Welcome to The Explainer. Today, we are diving into what looks like a classic magic trick, one that uses just a single drop of liquid to show us a hidden world inside the food we eat every day.
So let's just jump right in with the big question. You've got this simple, unassuming brown liquid.
So how can it create this really intense, inky blue-black color that shows up in a flash? We're going to break down exactly how this works, and trust me, it's not magic. It's all about molecular architecture.
Okay, so to get to the bottom of this, we've got to meet the main player, the real star of our show here, starch. Now, you might think starch is just, well, starch, but it's actually made of two key parts, amylose and amylopectin. And the crazy thing is, the difference in their shape is what makes this whole reaction possible. It's everything. Okay, so check this out. You can see the difference right here. Amylose, it's got this beautiful, long spiral shape, kind of like a spring. But then you've got amylopectin, which is all branched out and bushy. And that one little detail, the spiral versus the branch, that's the secret to the entire mystery.
All right, so we've got our iodine and we've got our starch. So how do they actually come together to make that incredible color change happen? Let's take a look at what I like to call the chemical handshake. Like we said, the secret is all about that spiral shape. Just imagine the amylose molecule is like a tiny, hollow spring. That spiral creates a perfect little tunnel running right down the center, and it's basically designed to trap other molecules. So, here's what's happening. The iodine solution has these things called triiodide ions, and they are the perfect size to just slide right inside that amylose spiral. They line up one by one, making this long chain inside the starch. And when that happens, this new combo, the starch-iodide complex, it absorbs light completely differently. And what we see is that amazing blue-black color. The coolest part? It's not a chemical reaction in the classic sense. It's a physical trap.
And that right there explains why amylopectin doesn't do the same thing. Remember how it's all branched? Well, because of that, it can't form that perfect little tunnel. The iodine has nowhere to go, nowhere to line up, so no complex, no color change. It's really that simple.
Okay, so that's the science behind it. But how do you actually do this test? Let's walk through it step by step. You know, what's so great about this is how easy it is. You really only need a few things. You need your sample, of course, some food, a plant, whatever. You need an iodine solution, a dropper, and a little dish. That's it. It's got to be one of the most accessible experiments out there. And doing it is super easy. First, just get your sample ready. If it's a solid like a potato, just mash it up a little with some water. That helps release the starch. Then, you just add a couple of drops of iodine and watch. It happens almost instantly. Okay, now here's a really cool trick that actually proves the whole theory. If you take that blue-black mixture and you heat it up, the color just disappears, vanishes. Why? Well, the heat makes that amylose spiral unwind. And when it unwinds, it lets go of the iodine. But here's the best part. As it cools back down, the spiral winds itself back up, traps the iodine again, and boom, the color comes right back. It's the perfect proof that it's a physical trap.
All right, so you've done the test. Now what do the results actually mean? How do you read the signs?
This part couldn't be simpler. If you see that deep blue-black color, that's a positive result. It means you've got starch. If nothing happens, if it just stays that brownish-yellow color of the iodine, that's a negative result. No starch. But, you know, like with any scientific test, there's always some fine print. No test is absolutely perfect, so it's really important to know what its limits are.
So, a few things to keep in mind. First, this test is qualitative. That just means it tells you if starch is there, but it won't tell you how much. It's also pretty specific to starch, so it won't pick up on other things like cellulose. And you do have to be careful about false positives from some other molecules, and know that it doesn't really work if your solution is super acidic.
When you think about it, that one little drop of iodine does so much more than just stain a potato. It literally makes an invisible molecular world visible to us. It shows us that this incredible, perfect spiral structure has been hiding in our food the whole time. And it kind of makes you wonder, right? If a test this simple can show us all that, what else is hiding right there in plain sight?